Good morning, everyone. Before starting, I would just to highlight two aspects. First is my co-authors, Anthony King, Roger Price, Ansa, and Jan Hendrik. Without these people, this work would certainly not have been possible. Secondly, I would like to highlight that as with most entomologists, we like to change things. The name of the felted Coccid has changed now, is no longer, the new name is, as you can see, is Acanthococcus, but unfortunately the insect is still the same. The felted Coccid, it's an old pest. It originated in Australia and possibly been there forever, but it really first became noticeable in the 1970s. For macadamia growers in Australia, it's really not a serious pest. Occasionally you'll see the odd flare-up when the guys are using maybe harsh contact sprays, but essentially it's really a pest of little concern. I wouldn't say no concern, I'd say little concern. Around about 2005, it found its way into Hawaii, and without its natural enemies, and it spread very quickly. By 2009, it was spread throughout the main island, and it became really a serious issue for the people there, and so much so that they had to release federal funds to address the problem. Unfortunately for us, for South African industry, it found its way into South Africa as well, 2017. And unfortunately, it was moved around by infested plant material. It's currently the insect is spread. I would like to refer to a primary spread where it has been moved with plant material in the Barberton Valley. There's a number of locations. Then White River Nelspruit area, also quite a number of locations. And then where there's single locations, places like Kaapse Hoop, Oorigstad. It has also spread to KZN, but it has very possibly been eradicated. We will need some information on that. What has happened since then is that it has spread to a number of secondary sites in the Nelspruit, White River, Barberton area as well. In other words, areas that didn't buy infested plant material, and this is quite a reason for concern. The bottom line regarding the spread of this insect is that it is a pest of considerable significance, and it's extremely invasive, and we should really take a lot of care to limit its spread. If you can see there on the slides, if you look very carefully on your right-hand side, you'll see what you'll see there is not a blob. It's actually a scale insect that was turned around. The female is that brownish thing that's sitting next to the eggs, and on its side you'll see there's like a little stylet, and that is its mechanism of being spread by the wind. At the moment, it's mostly being spread, or has been spread by the movement of either budwood or plants. It's very easy for them to hitch a ride on clothing, hitch a ride on equipment, even birds flying into the orchards. And I mentioned the wind as well. Interesting enough is that the colony at Roodeplaat, at Plant Health, from the ARC, basically they fed so much on the trees that they killed the trees. Trees were cut down, allowed to grow out again, and when the guys had a look, the Coccids were back again on the trees. So again, people, the bottom line is that these insects are fairly robust, and they seem to be able to do what nature gave them to do. They spread their genes far and wide, and this is not good news for the industry. Now, how do we know if there are Coccids in the orchard? Very difficult. First, you'll see the inside of the inside leaves of the tree would become necrotic. They would start dying. When you kind of go look closer, you will see the scale-like insects on the stems, and I'll show you some pictures. There's one of the only scale-like insects that will feed on the main stems, the twigs, the branches, the leaves, as well as the nuts. And here you can see on the slide the picture on the far left-hand side is a young tree. If you look carefully, you'll see the leaves just about turning brown. Close up in the middle slide, and then you'll see larger portions of the tree becoming necrotic on your left-hand side. What happens here is that, unfortunately for us, whether it is because of our pest management program that is based chemical based, or because we simply do not have natural enemies in South Africa, that these insects multiply extremely quickly. In Hawaii, the indigenous parasitoids were able to control about 60% of the insects. In South Africa, it's significantly less than 5%. Just show you a slide of the adult parasitoid, and then of one of the scale covers that had a hole made by one of these parasitoids. They are here. They unfortunately not doing a major job for us at the moment. These parasitoids we have not identified at the moment. Just showing what then happens without the parasitoids. We mentioned that large parts of the tree will die due to the feeding activity of these insects. And if I look at the economics, is that these trees do not recover. These dead parts. Farmers have to prune it out, and one obviously then have quite a significant crop loss, and obviously this loss is then compounded over a number of years. That's the end of the bad news. Fortunately, there are good news as well. The insect growth regulators that we are currently spraying, mixed with oil, works extremely well. If we spray it make sure that it's applied very well, it controls more than 99% of the scales. But there's also a downside to this, and this is that especially mature trees, you have to apply spray mixture right up into the main framework branches of the stem, and that requires a lot of volume, spray volume. Here we're looking at roughly about 10,000 liters, maybe up to 12,000 liters a hectare. And obviously this comes at an ecological as well as a monetary cost. And there's still some bad news, is that obviously this kind of feeding induces quite a lot of stress in the trees, and we now get a secondary pest, and I will show you some photographs of this as well. And these are a bunch of bark beetles. Some of them are indigenous, and some of them have been, well, we call it naturalized. They have been introduced over a number of years. Some photographs. You can see there on the right-hand side a close-up of the little holes that the bark beetles make. Some sawdust around the main trunk. And then on the far left-hand side, you will see a tree that has died due to excessive bark beetle feeding. Bark beetles, as we know, are by nature lured to trees that are under some kind of stress. So these are definitely a secondary pests, and come in where the trees have been stressed. Fortunately, we don't have to be scared too much. It's not the prolific shottle borer that we have not picked up, fortunately, at the moment. Just to look at the geographical spread, I'm pretty sure it's very likely that the spread is further than this. These are just the number of farms that we have picked up the bark beetles in the last 12 months. As you can see, it's Barberton, Nelspruit, White River, and then a little bit out on the N4 towards Gauteng. Interesting. There's definitely, and if you speak to the wine researchers, there's definitely a cultivar preference. This is the graft union of a normal tree. You can see the Beaumont rootstock is by far less selected than the cyan, the 816 cyan on top. What is also important is that the last year in an Nelspruit hazy view White River area, there has been a lot of scale insects that has manifested on a lot of trees, not only macadamias, also on lychee trees or on avocado trees. And this kind of damage is really very often confused with felted Coccid. As I mentioned before, the Coccid is the only scale insect that will affect all the above ground parts of the tree. Some of the other scales only affect either the nuts or the main stems. One of the scales we picked up is a white scale, the white peach scale. And I'll show you a photograph of that just now. And that mainly occurs on the main stem. It causes very thick incrustations on the main stem, and we've had many calls to come and have a look at them. And in most cases, it was not the felted Coccid, but some of the secondary pests. I will show you photographs of this, but the male Coccid is significantly smaller than the female. The male also have wings and can fly. The female is sessile, she cannot fly. She is a lot bigger than the males, and she has a very prominent opening at the posterior. If you look at these things, it's very easy to identify the Coccid. Also, if you look at the photograph on the screen there, you'll see that typically your Coccid infest the margins of the leaves and then along the midrib as well. And none of the other scales do that. Getting back to the photographs as promised, you'll see there the male, the right-hand side slide, you'll see the male emerging from its scale cover, and the picture on your left is the male with the male that's flying around. Photographs of the females on your left, you'll see the big sac-like covering of the female scale with the prominent opening I mentioned. On the right-hand side slide, you'll see males and females, and if you look carefully, you will see some crawlers as well. As promised, white peach scale, and you can clearly see the close-up that they look vastly different, and also the stem. It looks nearly like a kind of fluff on the stem, while the felted Coccid is more a solid, if I can use the word, incrustation. Chemical control. What we have noticed over the years, and also tallies up with what the guys in Hawaii has found, is that the Coccid becomes more dominant in the drier parts of the year. So from February, March onwards, we start noticing significant population increases. I mentioned that the insect growth regulator combination with oil works well, but it's not registered at the moment, and there are some registration trials going on it as we speak. How it works is that the oil smothers the females, and then the pesticide, the insect growth regulator, kills the crawlers. I mentioned the high volumes required. What I didn't mention is that some growers apply chlorpyrifos, dusban, in the mixture, and it had possibly a synergistic effect. It worked very well. The problem is that we picked up serious problems with secondary pests, and the secondary pest in this case was thrips. And this is something I would reconsider using in the future. I also tested some new nicotinoids, and I'll show you some of the results. It was not as good as was expected. As you can see there, we tested basically two products, thiamethoxam and imidacloprid. And although the scale of the slide make it slightly confusing, the differences among the treatments were not significant, and there's a number of reasons for this. The trial was done in May, just before winter. We figured that the sap flow in the tree was probably already decreasing because of the lower temperatures, and the translocation of the products from the place where it was applied to where it was supposed to work was not efficient. But the good news is that this insect is a prime example of where we can do very good control with classical biological control. This means that we have to import a parasitoid from its host range in Australia, and we've did that. We made contact with Prof. Mark Wright from the University of Hawaii, also an old colleague of ours. And this cooperative agreement was approved and accepted by the Americans, and we had a meeting this past July with the USDA, and where we formally decided that they will supply the parasitoid to us. This will reduce the cost for the South African macadamia growers significantly, as we do not have to go out to Australia and hunt for the parasitoid. One of the stumbling blocks that we had to overcome, that the Americans had to overcome, was to describe the parasitoid to science. It was new; it hasn't been described. That means it didn't have a name. That was done in March this year, as we were going into the lockdown period. If you want to Google that, the name is Metaphycus macadamiae. And I said the follow-up meeting was held, and in principle, all stumbling blocks have now been removed, and we can import the parasitoid into South Africa. Had a look at Scalenet, which is a international body where that look at various scale insects. Kylocorus and potentially Kylocorus nigritis, which is a black ladybird beetles, is listed there as a beneficial insect, and the practice of establishing bamboo thickets like they did in the old days of citrus could very well be considered. And then I think critically important is that the movement of plant material from Barberton, Nelspruit, White River area to other production regions should really be done only if you can be sure that there's no insects on them. We did some work on the surveillance, and the idea here was, because of Coccid-induced stress, the drone picked up stress plants, and you'll see in the slide there, very stressed plants will be listed there as red, and then orange and green and yellow, so on. And firstly, we went to some trees that we know were infested with the Coccid and had a look at how it showed up on the graph. And you can see about 80% of the Coccids are either red or orange on the graph. And then we went and had a look at the various color-coded plants, and there we had a similar grouping, about 80% of the Coccids. This is old Coccid damage. Well, either red or orange. What we couldn't prove, and this was the main aim of this study, was to pick up recently infested trees. Unfortunately, the drone couldn't pick up that, which is really a pity. To conclude, this insect is a game changer. If we are going to continue spraying harsh chemicals and we bring in this parasitoid, we're basically just going to kill the parasitoid, and it's going to give us serious problems. I think what the industry must really look at getting the scouting and spraying according to threshold level sorted, as it will reduce the impact of some of the broad spectrum products. I mentioned that a lot of spraying going on at the moment is still basically calendar sprayed, and we should really have a serious relook at that. Training scouts, training farmers, training reps, I think should be a cornerstone of what we want to achieve. And then lastly, I would like to thank a few people, SAMAC for funding, ARC for all their inputs, the various farmers, and what I didn't list here was the drone company, Aerobotics, for the data they supplied. Thank you very much. I have some slides. Let's look at the first question. Do you have to plan to experiment this parasitoid under controlled conditions before? The parasitoid can only be released once it has been proved not to be harmful to any of the indigenous indigenous insects in South Africa. So it will be scrutinized, and it will be tested in a quarantine facilities at Roodeplaat, and when we are 100% sure that it's not harmful to any of our indigenous insects, only then will we release it. The second question, maybe, and then I think I have to stop, is why do they become more abundant during autumn? For biological reasons, or when we spray less for stink bugs? I do not think it's because we spray less for stink bugs, because the same is happening in Hawaii. It's possible, and I'm just speculating here at the moment, that they prefer the more drier areas, the drier parts of the season. We're not sure at the moment. Maybe the last one, the information about why the parasitoid that I showed in the slide is not efficient in South Africa. You must remember that the parasitoid I showed you there is the South African parasitoid. It has nothing to do with Hawaii or Australia. This is a parasitoid that occurs in South Africa. It could be, we only have one Coccid species in South Africa, one indigenous Coccid species in South Africa. It could be that there simply is not parasitoids. And that is probably very likely the reason why it's not effective. And the second one that it may be is that because of the harsh chemicals sprayed in some of the farms, we are killing the parasitoids that are already there. Thank you very much.